If you want to make the world a better place, you should be an engineer, because we have that power to improve the quality of all of our lives. There are some disciplines that study problems, so you maybe understand what the problem is, but the engineer's job is to solve the problem. When I look into a young person's eyes and say, do you want to make the world a better place? And they go, oh yeah. Well, engineering is the field for them.
That's Dana Humphrey, the recently retired dean of the University of Maine College of Engineering. He may not run the college anymore, but he's still one of the leading recruiters, cheerleaders, and basic movers and shakers promoting engineering in the state of Maine. I'm Ron Lisnett, and this is the Maine Question podcast. Ability to improve people's lives, his eyes light up. It's hard not to get caught up in his enthusiasm. For 36 years, first as a faculty member, followed by a 16-year stint as dean of the college, Humphrey has been advocating for engineers and leading a growing enterprise that is filling a vital need in Maine. His track record is pretty remarkable. The college has seen enrollment grow about 70% in the last 20 years. Research funding has grown by some $25 million during that same time, and that funds a growing grad student program. From construction to the energy field, the environment, biomedicine, many other disciplines, UMaine Engineering grads are playing key roles in moving Maine forward, and the need is growing. There are multiple job openings for every engineering grad. UMaine engineers have a 99% job placement rate. The average starting salary for these grads tops $60,000. All that bodes well for the college as he enters retirement, but Dana Humphrey has left another major mark on his tenure at UMaine. The newly opened Ferland Engineering Education and Design Center, a project 10 years in the making, will transform the program and benefit the UMaine campus as a whole in many ways. At $78 million, it's the largest building of its kind in UMaine history. More than 500 donors contributed. The state of Maine invested $50 million in the project. We'll let Dana describe this amazing building during our chat. We talked about the building, of course, which is really his baby, the role engineering plays in the economy, what it takes to become an engineer, and his plans to finish a quest years in the making, namely completing his hike of the Appalachian Trail. Here now, our conversation with Dana Humphrey on all things engineering. Well, thank you so much for coming back and speaking with us here. First of all, I guess, how's retirement treating you so far? I noticed you haven't grown a beard like a lot of retired guys. All of a sudden they decide to lose the razor, but you haven't done that.
No, I'll probably clean shaven most days. I've only had a beard once in my life, and that was 40 years ago. I don't think we're going back to that.
So what have you been up to since you left the university?
So I volunteer with the Maine Appalachian Trail Club. We built our fourth privy on the Appalachian Trail, our third privy on the Appalachian Trail this year, just north of Monson. And then I've done an 8-day trip to Colorado, Wyoming, and South Dakota for hiking, visiting friends, and visiting family.
Sounds like a full agenda keeping you busy.
As most retirees say, I don't know how I ever had time to work.
Right. So 36 years at UMaine, that's a long time. Can you talk about what's going through your mind as you make this transition?
I've left the University of Maine with a great sense of satisfaction for all the wonderful students I've had the opportunity to have in class, for the great colleagues I've had at the University of Maine, for the progress we've made in the College of Engineering. So I'm leaving with a sense of satisfaction.
And we'll get to the building here in a little bit that we're sitting in doing this recording right now, but that has been sort of your life's work for the last portion of your career, is getting this new fantastic facility going, right?
Yeah, so the Ferlin Engineering Education Design Center for me was about a 10-year effort from the inception of the project to cutting the ribbon. And as a civil engineer, it has been a blast to be part of a project like this.
And to see it come to fruition. I mean, is it everything you thought it would be?
It's more than I thought it would be. The creativity of the architects and engineers who worked on the project was just tremendous. They were great listeners, and we have ended up with an awesome building.
So like we said, 36 years is a good chunk of time. Can you talk about the discipline of engineering? What was it like when you were becoming an engineer or studying to become an engineer? What are the biggest changes and what has sort of stayed the same?
When I became a working engineer, my first full-time job was in 1980. That was before there were personal computers. And so the biggest change in engineering is from calculators and mainframe computers to having a computer on every engineer's desk. And what that has done is it's allowed us to take and have this great computational ability right at our fingertips. It's allowed us to have computer-aided drafting as opposed to having drafters. In the company I work for, I had a whole room full of drafters. And that has just been transformational. It's made it so that engineers can work more efficiently, so they can do a better job refining their designs. But I'll say one thing that hasn't changed is that initial creativity that comes from the engineer's mind in terms of how do you solve this particular problem, that hasn't changed at all. There is no computer that's going to take and replace that creativity that comes out of the engineer's mind.
Gravity is the same as it always was, and forces and all that don't change, despite the tools you use to deal with some of this stuff.
That's correct. So we're not repealing the law of gravity anytime soon. So those things and the fundamental principles on which engineering is based has not changed at all. And so that part is constant. But what we do have was that computational ability is that ability to take and better refine our designs, better present our designs to our end users, and make better designs based on an ability to really gather and then analyze or make use of the data that's available.
I've heard you speak quite often about the need for more engineers. Can you expand on that? Why are they good for society and for the economy?
Yes, we desperately need more engineers. In Maine last year, there were 6 entry-level job postings for electrical engineers per graduate. There were 4 entry-level job postings for civil engineers per graduate. And we think about, well, that's fine. We can just do without the electrical engineers. We can do without the civil engineers. Well, one of the biggest transformations that's going to happen for the generation of students that's starting now is, what are we going to use for our sources of energy? That's going to take a tremendous amount of work for electrical engineers, and we need more. We take a look at our infrastructure. A lot of the infrastructure that we use today, it was built by my father's generation. It's going to have to be rebuilt by the current generation of engineers. We just don't have enough. We're in a world that's increasingly technologically complex, so even though computers, which we talked about before, allow engineers in some cases to work more efficiently, we still need more because of the technologically advanced world that we live in. And there are so many solutions that need to be created that we just need more engineers.
I've heard you talk before, and I can't remember the statistics, so maybe you know the ripple effect that one engineering job has on the economy, how it spills out, so to speak.
Yeah, so I'll pick an example that's close to our campus. I'll pick Old Town Canoe. They have 6 engineers that support the work of 300. You take away those 6 engineers, 300 people lose their jobs. And what's limiting the growth of companies in Maine today is, in part, they can't get enough engineers. If they could have more engineers, there would be more employment opportunities.
You've talked to many prospective and current students over the years and tried to get them to see how exciting a field this is. You're a civil engineer by training. What drew you to that particular discipline, and do you use your experience to help students when you were recruiting them?
I became a civil engineer ultimately because I'm just fascinated by construction. When I was growing up, I was the sidewalk superintendent. If there was a construction project anywhere within walking or bicycle distance of my house, I was there. And the only rule for my mother was I had to come home for lunch. And I was able to take and make the connection between my fascination by construction and civil engineering. And oddly enough, I never really thought seriously about going at this from the construction side. I really was oriented toward the design side. I wanted to be the one who was creating these wonderful projects that I was fascinated by them being built. And I was able to take and fulfill that dream in the early part of my career, all the way up to the end, culminating in the Ferlin Engineering Education and Design Center.
Now, I remember when you were on the faculty, cutting up tires to build roads with was one of your big projects, right?
So the biggest focus of my research was reusing scrap tires. And this was by taking them, cutting them up into pieces between 3 and 12 inches in size, depending on what the application was, and using them for lightweight fill for highway embankments, lightweight backfill for retaining walls, insulating layers beneath roads, drainage layers, and landfills. And one of the things that I'm very pleased with is that when I started this work, Maine had about 30 million tires sitting in piles scattered around our state. By the time I wrapped up the work, with the help of many, many, many others and a sustained effort, there were virtually no tires in piles left in Maine. And a lot of those went into civil engineering projects.
That's great. So as you move into retirement, what would you say about the state of the College of Engineering here at UMaine? Where do you think it's headed?
I think the College of Engineering is extremely healthy. We've had about 70% growth in the number of undergraduates, and that's really a concerted effort to try to take and graduate more engineers to help fill that demand. When I look back to about the year 2000, and then moved 22 years ahead to now, in 2000 we were doing $5 million worth of research per year. Now we're doing over $30 million of research a year. And that's creating the new technologies that are vital for our future. Now, the College of Engineering isn't done. It's certainly not static. I think the next big area where we're already starting to see growth is in our graduate student population. For this fall, the incoming class of master's degree students is up about 67%, and the incoming class of PhD students is up by 200%. And that's really in response to faculty that are dedicated to the balance between quality teaching and quality research, the growth in the research dollars which are needed to support the graduate students, and that has seen tremendous growth.
What are some of the new areas here that are growing now? Bioengineering and dealing with energy is one, but those are some, fair to say, newer areas here in the college?
The newest degree in the college is biomedical engineering. When we walk into a doctor's office or a hospital and we see all that technology, that didn't come from MDs, that came from engineers. And in response to that, we created a program in biomedical engineering. And there's tremendous advances in terms of the contributions an engineer can make to diagnosing a patient who potentially has cancer, to how do we take and treat that cancer, how do we take and monitor the vital signs of a patient. And so those are all things in the biomedical area that we're actively working on. And we think about some of our other areas I'll take an example from civil engineering. One of the roles of a civil engineer is to take and maintain and improve the quality of our environment. And we as humans, we have done some stupid things with our environment, and we generate waste materials every day that need to be properly treated. So one of our faculty members, Owner Uppel, he is using nanobubbles, so very, very fine bubbles of air to take and improve treatment processes. So you think, well, air, we've got that all around us, so certainly that's not a hazardous material, but if you can make the bubble small enough, it can be very effective at treating some types of materials. So that's a major advance. We have a very strong program in electrical engineering and electrical engineering technology, in power generation and power transmission. That's going to be vital as we take and alter our sources of energy.
We're sitting, as we talked about, in this new building that in many ways is sort of your magnum opus as you leave the university. Can you talk about the significance of the Ferland EEDC building? What's it going to mean for UMaine? Obviously, it means a lot for the College of Engineering, but for UMaine and for the state and even beyond.
First, for the College of Engineering, this, for the first time, gives us a place where students can work collaboratively together on projects. When I say work together, this is cross-disciplinary. The heart of the building is the Student Project Design Suite, where we have 44 workbenches we can assign to a group of students for a semester or a year. That's not space owned by a department. That's space for the entire college and all the students in the college. And the workbench space is surrounded by shops. We have shops for biomedical engineering, electronics, 3D printing, a tool crib, vehicle shop, metal shop, wood shop, and composite shop. This is the best space of its kind in the Northeast, and it's here at the University of Maine. And we're going to have students from biomedical engineering working with students from mechanical engineering technology. We're going to have students from civil engineering working with mechanical engineers. And we needed this space to be a catalyst for those students to take and come together and work. And not only do we have that space where we do great things in the space, it's a lab that's on display. You walk up and down Main Street, you can see all the cool things that are happening in there. You walk up and down Beddington Road, which is right adjacent to the building, looking through all the windows, and people just be inspired by seeing all the cool projects that are happening in there. Now, we take and think about, well, what does that mean for the college in terms of being able to recruit students? Well, we're going to keep more students who want to be engineers in Maine because of that great space. And we're going to be able to attract students from across the Northeast and beyond because of that great space. And that's going to take and help address Maine's shortage of engineers. Now we think about, okay, what beyond that does it really mean for the university? Well, there are 5 collaborative classrooms in this building where the students sit in groups of approximately 6, where they can take and work collaboratively together on projects under the guidance of the faculty member. Very different from the mode of instruction when I went to school 45 or so years ago, where my job was the scribe. The faculty member wrote something on the blackboard with chalk. I would frantically copy it down in my notebook, and then that night I'd try to do the homework problem. And what made sense at 9 a.m. made no sense at all at 9 p.m., and there was nobody to ask. So with a collaborative classroom, students can take and do some of the information transfer outside of class, then come together and work under the faculty member's guidance on problems. That results in deeper learning, more permanent learning, and it prevents the head scratching that I did a lot at 9 p.m. trying to figure out how to do homework problems. And those 5 collaborative classrooms are for the entire university. So I'm sure as we sit in the Ferlin EEDC today, there are classes in history, there are classes in speech, there are classes in science, and certainly classes in engineering. They're being held in this building because those are for the entire campus. And then beyond that, we have the campus Welcome and STEM Outreach Center. This is on the first floor at the north end of the building, and this is where all campus tours will start. So when a prospective student who's going to major in engineering or philosophy or nursing, when they come to campus for their tour, they're going to start at the Campus Welcome Center. And they are going to get to see this fabulous building, like most folks, they come a little bit early because they don't want to be late for their tour. So they're here early enough. They go to the south end of the building. We have the student commons, which has food service, so they can get a bite to eat while they're waiting for their classes, their tour to start. They're going to walk up and down the halls and see the great things that are happening in laboratories. So this is not going to attract only engineering students. This is going to attract students from all disciplines that we have at the University of Maine. So this is a resource for the entire campus. And then we take and expand this to what does this mean for the state. As we take and keep more Mainers in Maine and we attract more folks from outside of Maine, that's going to help to address Maine's overall workforce shortage, where we just need more people. We just don't have enough.
And that was the design of the building from the beginning, that it was going to do all these things for departments and colleges and in the entire institution and beyond.
It was, that this is a building certainly for engineering, but it's a building for the entire university. The genesis of the campus Welcome and STEM Outreach Center, that actually started with me. We had a visioning session at the beginning of the design, and the idea just popped into my head that we needed to have this in the building. Once the idea was there, I never let go, even though there were pressures to eliminate it so we could fit in more engineering stuff. I made sure it stayed in the building.
Well, you were clairvoyant, a stroke of genius right there.
Well, I don't know quite about that.
So you've recruited thousands of students, I'm sure, during your time here. What's your pitch to them? How do you get them interested in trying to become an engineer? What are some of the traits that you look for someone to be successful in their path to become an engineer?
The reason students should become engineers, and kind of part of my sales pitch, so to speak, was that if you want to make the world a better place, you should be an engineer, because we have that power to take and improve the quality of all of our lives. There are some disciplines that study problems, so you maybe understand what the problem is, but the engineer's job is to solve the problem. And so when I look into a young person's eyes and say, do you want to make the world a better place? And they go, oh yeah. Well, engineering is the field for them. It also is good that there's tremendous demand for engineers. As we talked about earlier, our placement rate is 99%. The starting salaries are well up into the 60s and thousands, and in some cases even more for our students. So you can make an excellent living as an engineer. You take and combine those things together, it can be a very satisfying profession. And examples that I use are my sister Diane, actually. She's a mechanical engineer. She got to retire pretty darn early because of the great career she had, and she couldn't have done it without being an engineer.
Well, you've sold me on it. If I could do the math, maybe I would go back and give it a shot. But I think that ship has sailed. So
well, but certainly engineering is based on math. Math to an engineer is a tool. When I think back to my time in the early 1980s working as an engineer, most days the hardest math I learned in ninth grade. I needed to find X, and it was on the wrong side of the equal sign. So I need to kind of rearrange things a little bit. And so when someone is thinking about being an engineer, they shouldn't think only that, okay, it's got lots of math. Math to an engineer is just a tool. Right. And we use that tool as we need to take and help us solve problems. But we're not mathematicians.
Right. So we talked about the new building, and obviously this is a very big first step in the very big plans for engineering here at UMaine. What's next as far as you can tell? What for the program and 5 or 10 years down the road, what else might we see when we look at the College of Engineering?
So I think what we're going to see is the Maine College of Engineering, Computing, and Information Science, where we're taking and bringing together the power of engineering and the power of computing. And there are so many synergies with artificial intelligence, between engineering and computing when it comes to advanced manufacturing, when it comes to making better decisions. And I think that's going to be incredibly productive. And the Maine College of Engineering, Computing, and Information Science will in some form extend across the entire system. Because if we're going to take and produce the number of engineers and computing professionals that this state desperately needs, we've got to work together as an entire state to make it happen. And one thing that's quite unique in Maine relative to all the other states in the Northeast is how much reliance is placed on the public university system to produce the engineers, produce the computing professionals. And so the system has to work together to be able to take and meet that demand. And as they're successful in doing that, the entire state of Maine will benefit. There'll be more opportunities for its citizens. We're going to have a stronger economy, and it will still be a great place to live.
So as we wrap up here, what's next? Have you gotten rid of your hard hat? Any big plans? I know the Appalachian Trail has been something that has occupied your time away from being dean of the college here. How close are you to finishing that, and is that on the bucket list right now?
Yeah, so in the month of October, I'll complete the Appalachian Trail.
The whole thing, the last leg.
The last leg. I'm a section hiker, meaning I've been hiking it in chunks, and I'm going from north to south. So in the parlance of the trail, I'm a SOBO, meaning I'm southbound. And I have 275 miles left from Hot Springs, North Carolina, to Springer Mountain in Georgia. Yesterday morning, I actually made my campsite reservations to go through Great Smoky Mountain National Park. So I'm all set, and I got every day that I wanted. There was availability at the shelter I'm going to be staying at. So I'm ready and raring to go for that. Beyond my love for hiking the trail, I'm also dedicated to giving back to the trail. I'm very active in the Maine Appalachian Trail Club that maintains the Appalachian Trail in Maine from Grafton Notch to the border of Baxter State Park. And my specific role there is to take, I'm in essence the foreman, to rebuild all the privies on the Appalachian Trail in Maine. We rebuilt number 21 on Labor Day weekend. We have roughly 44 total, so we're almost halfway. Wow. And if things go well, we'll finish in 2030. And this is an effort that has 25 dedicated volunteers that just put their heart and soul into making this happen. And we also get help from other groups to take and put this together. And that's an amazing organization that I'm very happy to take and give back to.
Now I know for anybody that hikes the AT, you have a trail name. What's your trail name?
My trail name is D6. That's a Caterpillar D6 bulldozer, a really old one stuck in first gear. He just keeps chugging along. And that's what I plan on doing, is just keep chugging along, both with my hiking work, my work at my wife Barbara and I's farm in Palmyra, Maine, because just because I'm not employed and getting a paycheck doesn't mean I'm slowing down.
You're busy.
There's lots of things that I just love to do.
It's been so great dealing with you over the years, and best of luck in retirement. Thanks for taking the time to talk to us.
Thank you, Ron.
Thanks for tuning us in. You can get all of our episodes in a number of places: Apple and Google Podcasts, Spotify, Stitcher, and SoundCloud, as well as UMaine's YouTube and Facebook pages. Please consider subscribing if you like what you hear. Drop us a line with any questions or comments at mainquestion@maine.edu. This is Ryan Lisnett. We'll catch you next time on the Maine Question.